There's a little girl named Jennifer, curious about how a snowman will melt. And we're here to present and explain to her the scientific process of it. So here is a picture of a snowman at the macroscopic level, and it shows the water dripping from the snowman. That is proof from your eyesight that it changes its state of matter, from solid to liquid. Now I'll zoom in and show the particles. Since this is a phase change, it is the melting process. It goes from solid to liquid. Before the snowman is melted, it is in the solid state. And when it's in the solid state, the particles are tightly packed and are only able to vibrate. When it goes to a liquid state, the molecules slide past one another and have little space in between them with no arrangement. You see, Jennifer, the snowman was first in a solid state only because the molecules remained in fixed position by intermolecular forces. What is intermolecular forces? Intermolecular forces are forces in between atoms that are usually what holds the particles together. For example, the particles in a snowman are being held by hydrogen bonds. If there were no forces, then the molecules would be separated and will always be moving freely like gas. The heat source will come from the sun, and this is what causes the snowman to melt. So yeah, Jennifer, the snowman does melt because of the sun, but there's more to it. During this phase change, a snowman melting is an endothermic process. Endothermic is energy and heat being added or gained. So Jennifer, if you add heat to something, of course it's going to melt, and it's going to change its state of matter. One way these forces can be broken is by the process of conduction. Conduction is the transfer of heat from one particle to another while colliding. Since heat is being added to the snowman, the forces start to break. The only reason the forces start to break is because the heat heating up the solid particles make them start to vibrate very fast and separate, turning into a liquid. A big part of conduction is the collision process of the particles. If particles don't collide, heat transfer won't occur. However, gas particles aren't held together by forces. They are moving too fast and are too far apart for conduction to occur. Liquid particles are closer together and collision does take place, but in solids they are much closer and have better direct contact with each other. Jennifer, that's why solids are the best for heat transfer. So Jennifer, this whole time what I've been trying to explain to you is during the melting phase, molecules go from solid to liquid, same as from vibration to translation. The molecules from the atmosphere collide with the snowman particles. This causes a lot of kinetic energy. This will help break the intermolecular forces because there's little more energy for the molecules to escape. And there's heat being added which causes the forces to break down. So may the forces be with you. If you didn't know, a snowman melting is changing only its appearance, meaning it's a physical change. A physical change is a change in appearance, but the composition or the makeup stays the same. The snowman's makeup is H2O, so even before or after the snowman melted, it stayed H2O. That's what makes it a physical change. Don't want to get too much off topic, but on the other hand, a chemical change involves one or two more substances creating or changing into a new substance, like iron with oxygen turning to rust. I hope I was helpful to you and Jennifer, so thank you for watching.